Hello, I'm standing here in front of the Lucas Nulle training equipment in photovoltaic hybrid systems. Hybrid means that the system can be powered by different sources. These systems are conceived to ensure power supply in areas where this supply is critical. Students must now prepare to be able to operate, design, and install such systems. I will start by briefly describing the components of the system. We start here with the connection point to the grid, accompanied by a smart meter which transmits information to the Scada. And here we have a power switch which allowed us to connect or disconnect the grid easily. In the middle, we have the most important element of the system, the battery-powered inverter. This device, a part of operating as an inverter with battery management, also has a solar charge controller with MPP, and also an AC charge controller, so the battery can be recharged when the capacity level is too low, for example, at night. This device also has a measurement module which collects data and sends it to the Scada. On the right side of the inverter, we will find two types of loads, which will help us to investigate the variations on the system depending on consumption. In these systems, we have two types of different generators. The first one is the photovoltaic system, which is built up with this DC control power supply, together with the software, the solar panel emulator, which will help us to set different irradiance values. On the other hand, we could also load a solar profile to emulate the behavior of the system during a specific period of time. Apart from the photovoltaic system, it is also possible to connect the small wind power generator. If we do so, we can expand the system to form a small microgrid. And here, on the bottom part of the system, we find our battery. We will use this measurement device to display important values like voltage, current, and power. Now, I want to show you the Scada interface that will allow us to observe everything that is happening in the system. As you can see, the measurement values at the different points of the hybrid system can be monitored in real time, which makes for the students easy to understand how the energy flow and the different types of operation works. Along with the system, you will find an interactive course that can be installed on a PC. The multimedia platform used here is called LabSoft, and it allows you to display theory, setups, practical exercises, and perform real-time evaluation in a very user-friendly way. Additionally, each course has different virtual instruments that will make the configuration of devices and data acquisition easier. We have prepared the wiring of the system before, but the wiring is always available in our course. Now I'm going to connect the battery to the system, and you can see that the system directly starts working, and the load is being powered by the battery. Now I will connect the grid. Other operation modes are possible, even maximizing the autarky. Now I would like to show you the second mode. Using the integrated charge controller with MPPT, we can connect a photovoltaic facility to recharge the battery. This configuration corresponds to an island operating mode. Using the solar panel emulator that I have mentioned before, we can set a fixed value for the irradiance, or we can load any solar profile to emulate the irradiance curve for any time of period. I will set a fixed value here so you can observe better what is happening in every phase. If the solar irradiance is enough, the photovoltaic system starts to deliver power. If the solar irradiance is enough, the photovoltaic system starts to deliver power. Depending on the amount of power produced, it will be distributed to supply the load and to recharge the battery. If too much power is produced, the system cannot process it, and consequently, depending on the battery charge status and the load, the working point will not be at its maximum, but instead it will be at a reduced value. If the value of solar radiation is very small, then the load will be supplied together by the battery and the photovoltaic system. Now I would like to explain you the next operation mode, which includes the connection of the small wind turbine. For doing this, I will disconnect the photovoltaic system so we can perceive the differences that are happening on the system. For doing this, we will need to use the virtual instrument Wind Control Center, which can be found in our labs, of course. I will set control by wind and select a value of 8 meters per second. Okay, now I will enable the instrument, first starting the recording, so I am able to see some parameters here. And when I start, we can see on this diagram how the voltage is rising. But this is not all. We can also show some other parameters which are important for the system. For example, the current and the active power. So right now, our system is being supplied by a second generator, in this case the wind turbine. The loads are being supplied together by the wind turbine and the battery. Further experiments are possible, of course, and then you can find them on our labs, of course. I will stop the wind turbine now. There are other possibilities. For example, we could connect a solar pump to our system as an alternative generator. Additionally, we can connect the real wind turbine or the photovoltaic module. This new photovoltaic hybrid system will become part of our power engineering lab, which you can see on the background. Important parts of this lab are wind power plant, microgrid, smart grid, energy management, and professional photovoltaics. This is all for now. I hope I have caught your attention. For more information, please visit our website.